Hello all, hope everyone is doing great. Welcome back to my channel Build with Swinder. As part of this video series today, I'll be building the logic for this Leetcode problem 104, which is the maximum depth of binary tree. In this we have to find the maximum depth, which is the number of nodes along the longest path from the root node down to the farthest leaf node. In this case, these two are the farthest leaf nodes, so we have to find the maximum depth, which will be the longest path from this root node either to this leaf node or from this root node to this leaf node. So how could you solve that? Generally, to solve tree problems, you have two kind of approaches, BFS or DFS. I'll just show you the DFS way first because this one is more intuitive. So how to solve this problem using DFS? Before that, you need to understand how recursion works. So let's say you are given this tree, okay? What do you think will be the answer of the this problem, maximum depth of a binary tree, if this is the root node? Let's assume that the left subtree is giving me the maximum depth as L, the right subtree is giving me the maximum depth as R. So now what will be the answer here at this particular node? Can I say that it will be 1, which is this node, plus max of L comma R? Can I say that? This L is the maximum depth of the left subtree. This R is the maximum depth of the right subtree. If you believe this is true, then it will be very easy to find you the answer. I know it's a bit trickier because back when I used to learn recursion, I used to find it very hard to understand how recursion works because I used to think too deep going into the recursion. But one of my mentors said that you have to stop thinking like how the recursion goes so deep. You have to stop thinking that. You just have to think by standing on a particular node and then take the decisions what will happen. So let's say if I am standing at this particular node here, this node, what will be the maximum depth? So if I'm standing at this node, the maximum depth can come either from the left subtree or from the right subtree. If I believe that the left subtree is giving me L, right, and the right subtree is giving me R. So for this node here, what will be the maximum depth? Either it will be coming from L or from R plus 1. 1 is coming from this node. Can I say that? Okay. So you have to have belief in recursion that it's gonna work. If you believe that recursion is working, then you just have to give the base case and it will work. It's like a kind of a magic. Okay. If your base case is right and you are making correct decisions while standing on a particular node and you are doing the same for each node, then your answer will be correct. Okay, so let me write you the pseudocode and we'll see if it's making sense or not. So let's say you are given the same function to find the maximum depth. Here I'm given a root node for which I need to find the depth. Okay, there will be a base case here. Okay, I'll write the base case later, but let's say you are given the answer for the left subtree. Okay, so the max depth for the roots left subtree, you know its answer, it's left. Similarly, you can assume that somehow you know the answer for the maximum depth for your right subtree. We know that the answer for the current tree where the root node is root would be 1 plus max of left comma right, provided this left and right are the right answers. Now you have to think of a base case. So let's say what will be the base case? How can you come up with a base case? Let's say you are just given one node and now you have to find the maximum depth by going to the left subtree and to the right subtree. but the left subtree is null. Now, that would be your root case. That would be your base case, sorry. So if root is equal to null, what will be the depth here? It's empty, right? There is no depth. So you just return 0. You return it 0 in this case. So here you will be getting 0 from here, 0 from right subtree, and then you will just return 1, which is correct in this case, right? So if you can think of the answer for this particular subtree and you do the same for each node, then you will get the right answer. So this will give you the right answer. If you just don't have to go too deep into the recursion. You just have to think while standing on a particular node, what's gonna happen if I'm standing at this particular node? What will be the answer? If you can think of the answer for this particular node and you have the right base case, then you are good to go. So this will give you the correct answer. Let me just give you the what will be the time complexity of this solution. You will be visiting each node at max just once. So the time complexity would be O of n, where n is the number of nodes. The space complexity would be O of h, where h is the height of the tree. When you are doing recursion, there is a memory consumed by the stack trace, which is the height of the tree. In the worst case, this h could be equal to almost equal to n when your tree is skewed. So the space complexity would be O of n in the worst case. Okay. Now I'll show you the another way of solving the same problem using BFS. In this, you will be traversing the nodes level by level. So initially, you will be visiting all the nodes at this level. Then you will check if the nodes at this level has left or right children. You will add it to the next level. So then you will be visiting all the nodes at this level, and then you will be visiting all the nodes at this level. And while you are doing all this, you will be maintaining the depth, which is the what depth have you seen so far. How will you be visiting these nodes? You could just use a queue. So let's say you have a queue here and you have a depth. Initially the depth is 0. Okay. And you will just offer the root node to your queue. Now I'll just write the standard BFS way of doing problems. So you will have to iterate while your queue is not empty. If your queue is not empty, then it means there are some nodes which you need to traverse in the current level. Okay, so I'll just traverse all the nodes in the current level, but first I need to know the size of the current level. So what is my size of the current level? Why I'm doing this, I'll get back to you guys later. You will understand why I'm doing this. So now you will traverse all the nodes at this particular level. Okay, if there are 5 nodes, so this loop will run 5 times, and you will be extracting each node from the queue, and for each node you will be checking if this node has a left child or not. If the left is not equal to null, then it means you need to add this node's left child to the queue. Similarly, if the right child of this node, sorry, it will be right here, so let me just do it again. So if a right child of this node is not equal to null, then it means you have to add the right child of this node to the queue. Now you will see here, I am adding the right child and the left child to my queue. That's why here I'm checking the size first. Otherwise, if I don't check the size, then all of these nodes are will be processed in the same level. So that's why I'm checking the size here. So this size will make sure that all the nodes at a particular level are traversed before processing the other nodes. Okay. So initially my depth is 0. So there is one change that I need to make. So if the queue is not empty, it means there are some nodes which I need to traverse at the current level. So here I'll just increase my depth by 1 because I know that I have some nodes to process. So I'll be processing them. So in the end, what I need to do is I just have to return the depth which will be the answer. Okay, so if you check here, what will be the time complexity of this solution? The time complexity would be here. I'm traversing each node at once. I'm just adding each node just once in my queue. So the complexity would be of n, and the space complexity would be also of n, because at max I could just add all the nodes to my queue, right? If all the nodes are at the same level, then I could just add all the nodes, which will give me the space complexity as of n. Now I'll show you the same problem on the Leetcode, and we'll try to solve it using DFS way, which I showed you earlier. So here is the same problem on Leetcode, and I'll just write the DFS way. So first we have to write the base case, which is if root is equal to null, then it means the depth is 0. Otherwise, the depth would be max of max depth of the root of the left child, right? Here I'll be passing the right left child, or it would be the max depth coming from the right child. So this will be the, see how easy it is. If you are not thinking too much about the recursion, you just know your base case is correct, then you will find it easy to solve. So all the base test cases passed. Let me try to submit it. Yeah, so it's passed. I hope you guys understood the problem and the solution. And if yes, please like this video and also subscribe to my YouTube channel. I will be posting more such videos. See you guys.